Okay, so this is a question in the vector chapter that require to find the shortest distance from a point to a given plane. Usually they ask you in separate steps, but then if you look at this question, you need to break it down into at least three major steps. So step one, we find a line that goes through the given point A, and it's perpendicular to the plane. And then we say this line intersects the plane at point H. Because that gives you the shortest possible distance. And step two, what we do is that, okay, so we need to find the point of intersection. And then step three, and then which is H, right? So we find the point of intersection H, and we know the original point A, so we can find the distance H. So we keep that in mind in these three different steps. So okay. Step one is the most important one. So we need to create a line that goes through the given point A and is perpendicular to the plane. So we can see for a line we have a direction vector. So the direction vector of the line, which is D, is the same as the normal vector of the plane. So that is one of the most important things for the question. And from the given equation of the plane, we know the normal vector. Normal vector of the plane is basically the coefficient of x, y, and z, -1, 2, and 2. So this is also the direction vector of the line. And then the line goes through a point A, right? So A can be used as a position vector. So for this line, we can say R equals to the position vector, which is A, plus T times the direction vector, which is the same as the normal vector of the plane. So then we finish the first step. So the second step becomes like we need to find an intersection of this line and a given plane. So we need to do substitution. So the vector equation from step one, we change it to the parametric form. Remember, R is essentially just x, y, and z, right? So, but then we erase this. We write x equals to -2 plus t times -1. I just simplify -2 minus t, y equal to 10 plus 2t, and then z equals to 8 plus 2t. And now we substitute this whole thing into the given plane to find the intersection. So we substitute that. So we have negative x plus 2y plus 2 times z equals to 11. So then I need to solve this equation, which is just labor's work, so you can make it faster if you want. But I need to do it. Equals to 11, and then 90 altogether equals to what? So there's 22. So 22 plus 16 is 38. 11 minus 38, which is -27. So t equal to -3. Okay, so we have a value of t. We need to plug this t into the parametric equation of the line, then we find a point. So then x equals to -2 plus 3, which is 1, and y equals to 10 minus 6 is 4, and then z equals to 8 minus 6, which is 2. So that gives you the point H. So therefore H coordinate 1, 4, and 2. So that finishes the second step. And the third step should be the easiest one. And remember, A has coordinate, I just write it down again. And then H has coordinate 1, 4, and 2. So it's as simple as we find the distance between the two given points. You can find a vector of AH and then find the magnitude, but you can just apply the distance formula, square root, and the difference -2 minus 1 plus squared plus 8 minus 2 squared, which gives you square root of 9 plus, let's make it simple, okay, so 2, so 3 squared plus 6 squared plus also 6 squared. And let's play with that. We can take the 3 squared out, which is 1 plus 2 squared plus 2 squared. And then we take this 3 outside, which gives you 3 square root. That's pretty good. And so that's 9, right? Which is 3 times 3, which is 9.